What if I told you that astronauts aboard the International Space Station are aging slightly slower than everyone on Earth? It sounds like science fiction, but it's absolutely real. Welcome to the mind-bending world of time dilation. In 1905, Albert Einstein proposed something revolutionary. Time isn't a constant. It can speed up or slow down depending on how fast you're moving and how strong gravity is around you. This is the foundation of his theory of relativity. The faster you move through space, the slower you move through time, and the stronger the gravity you experience, the slower time passes for you. Let's look at astronauts on the International Space Station. They're experiencing time dilation in two different ways, and these effects are actually working against each other. First, there's gravitational time dilation. The ISS orbits about 400 kilometers above Earth. Up there, gravity is weaker than on the surface. Weaker gravity means time moves slightly faster. So this effect actually makes astronauts age faster than people on Earth. But here's where it gets interesting. The ISS is moving incredibly fast, about 28,000 kilometers per hour as it orbits Earth. This is velocity time dilation, and it works in the opposite direction. The faster you move, the slower time passes for you. For the ISS, the velocity effect is stronger than the gravity effect. The net result? Astronauts age slightly slower than people on Earth, about 0.07 seconds slower for every 6 months in space. Now, 0.007 seconds isn't much, but what if we could go faster? Much faster? Imagine a spacecraft traveling at 90% the speed of light. For every year that passes on Earth, only about 5 months would pass for the astronauts aboard. They could travel for what feels like 5 years, return home, and find that 10 years have passed on Earth. This is the famous twin paradox. If one twin stays on Earth and the other travels through space at near-light speeds, the traveling twin would return significantly younger. This isn't just theory. Scientists have proven time dilation with atomic clocks, the most precise timekeepers we have. In the 1970s, scientists put atomic clocks on commercial airplanes, flew them around the world, and compared them to identical clocks left on the ground. The flying clocks showed slightly less time had passed, exactly as Einstein predicted. Today, GPS satellites must account for time dilation. They orbit at high speeds and experience weaker gravity, so their clocks run at a different rate than ours on Earth. Without correcting for this, your GPS would be off by kilometers within just a day. So yes, space travel really does make you age slower, though not by much at our current speeds. But this opens up incredible possibilities for the future. If we could build spacecraft that travel close to the speed of light, we could explore distant stars within a human lifetime, at least from the traveler's perspective. Centuries might pass on Earth, but for the astronauts, it could feel like just years or decades. Time dilation reminds us that the universe is far stranger and more wonderful than our everyday experience suggests. Time isn't fixed. Space and time are woven together, and traveling through one affects how we experience the other. The cosmos isn't just waiting to be explored, it's waiting to teach us that reality itself is more flexible than we ever imagined.